A warm welcome to Shendra's Engineering Tutorials, another important video from the playlist Control Systems. That topic which is generally neglected, but you will have a certain surprise in the exam point of view. Generally, I don't know why you students neglect that. It may be because you are fed up with the derivation part. You may feel that it's a bit tedious and you leave it, but it will surprise you in the exam point of view. You may see that, you may come across in the question paper something about frequency domain specifications. You always focus on time domain specifications and you neglect frequency domain specifications. Even these are very important as compared to time domain specifications. And we have 5 frequency domain specifications, upon which among those specifications, two will be having utmost importance in the exam point of view, right? And everything starts from the transfer function of a second order system. What is that transfer function of a second order system, guys? You may be remembered. It starts the discussion which is linked up with the second order system starts from the time domain specifications itself. Time domain analysis from the second chapter. Time domain analysis. It says like this, isn't it? C of S is the output by R of S input to the system, which is equal to omega n square by S square plus 2 zeta omega n into S plus omega n square. The damping factor and the natural frequency, right? And whenever we speak about time, I mean frequency domain, frequency, that itself says S, this S should be plugged in with j omega, and then the transformation takes place. Wherever we come across S, that's plugged in with the factor S is equal to j omega, and then the calculation starts. Let's assume that C of S by R of S, this ratio to be some M of S, this together, this ratio M of S, more precisely M of j omega, straight away plugging in the value of S is equal to j omega in the expression. So guys, if this is the case, what will be, on the other hand, what will be S square? It should be j omega whole square, isn't it? That takes another form, j square, that's -1, right? So this will be minus of omega square, right? So straight away that over here S square, we have S and S square also. So it's plugging in these values. This M of S, this whole ratio M of S can be written as, it's a omega n square as it is in the numerator. Guys, this takes this form. So I'm writing that directly over here. It's a minus of omega square. This isn't omega n, okay? This is omega. This is working frequency in radians for different values of omega. This is a natural frequency in radians. Plus, guys, 2 zeta omega n as it is. 2 zeta omega n as it is. And we have the frequency component S over here that is plugged in with J here for you to understand clearly J, and omega comes over here, omega plus omega n square, okay? It's a square, please don't mind, it's a square. So taking out omega n square as common from all the terms, what we have, omega n square from the denominator. So taking out omega n square, what the resultant will be, omega n square is taken out. So here we have it's a minus of omega by omega n whole square. This could be written like this one, it's a whole square, okay? Omega has square and omega n also have that square, so totally it can be written like this one, okay? Going ahead, it's a plus j 2 times of zeta omega n, and guys, omega n has come out, okay? Don't mind, omega n has come out. So what will be left over here? It's omega as it is, and we have omega n in the denominator. Multiply this one, we'll go back to that factor. Let me show. Omega n square into, if this is multiplied with this one, we have omega by omega n, isn't it? So 1 gets cancelled, we have omega n into omega, we are back to this. So this is a simplification over here for a beginner, okay? So you'll be in a hurry, so you don't understand all these simplifications, so that's the reason. Plus omega n square has come out, so we have 1. Guys, this is the important step in evaluating something. Let me tell you what that something is. After I find out, if after I reach that place, after I reach that expression, okay, it's a m of j omega in the LHS, right? So guys, this gets cancelled over here, this, and what else? Of course. And guys, we have real terms and imaginary. Separating that one will give us, and one more simplification. Another simplification, we cannot write this ratio always. Okay, so omega by omega n, let that be simplified to, let's say it's a u, simply u, which is equal to omega by omega n. Wherever we have this one, omega by omega n, that's plugged in with u, which is known as a normalized frequency. Normalized frequency, it's a frequency ratio, and that is known as a, that's given the name normalized frequency. Okay, so with that assumption, with that simplification, this could be taken as, guys, m of j omega will be, it's a 1, this one minus this 1 minus, we just assume that to be u, right? So this will be u square plus, guys, it's a real one, okay? Yes, it's a real, and j 2 times zeta into u, right? So the magnitude of this one gives the magnitude on that side, okay? The magnitude separating the board, I'm going ahead of that side, okay? So the magnitude of m of j omega will give us m, okay? Will give us m, and how that is written for is equal to 1 by it's a 1 minus u square, closing the bracket, whole square, plus, if we don't have just j anymore, so magnitude of a plus jb, how to write down that? Under root a square plus b square, isn't it? We don't have this one. That's the way of writing the magnitude. In that case, it's a 4, straight away squaring to this one, okay? 4 zeta square and u square, it's a u square. We have that root, isn't it? Under root, we have that under root, okay? So that's for the magnitude m. We'll proceed with this one, m, okay? We don't have that j anymore, so this doesn't exist anymore, and this is transformation. And how this can be, guys, it's in the, this term, the denominator can be written in some other way. It's a 1 minus u square whole square plus 4 times zeta square u square whole, we have that root, right? So inverse, this could be, it's in the denominator, writing it in the numerator, it could be written as minus 1 by 2 root. That is a, that can be written like that one in a ratio. The numerator could be brought to the, sorry, the denominator could be brought to the numerator. And if that is the case, guys, we should go in search of some parameter that gives us differentiating the entire expression with respect to u, we'll reach to that expression which we are in search of. So dm by du in this case, entire expression with respect to u. Hope you remember this one, d by dx of x raised to n. What it is? N into x raised to n minus 1, and differentiating this once again with respect to x, isn't it? That will be 1 in that case. Come on, the same process over here. So this comes as it is to the down, I mean minus 1 by 2. This comes down for n as it is, into 1 minus u square whole square plus 4 zeta square u square, and minus half minus 1, that will be minus 3 by 2, okay? Again differentiating with respect to, I mean differentiating this entire term with respect to u. That's the procedure over here. It's into this one, with respect to this. So here have a watch, careful watch here. This comes down 2 times 1 minus u square, okay, 1 minus u square for this one. Again, with respect to here, we have u again here, over here, this will be 0, but we have to differentiate this again. So that gives us minus, we have that negative, and x square, it's a 2x, 2u, okay, for this one. And this will be guys, let me erase this one, okay, so that we can have a clear picture of that derivation. This is for, I repeat, this is one, this comes down, this repeats, I mean this comes as it is, this repeats, we have to obtain the derivative of this one with respect to u, so that we have negative 2u, okay, and that this one, it will be with respect to u, isn't it? So this comes forward, so that gives us 8, and zeta square into u. We don't have that u square again, it's simply u. So this is the entire expression. Guys, this could be again a small modification over here, dm by du could be written as minus 1 by 2 as it is. As this can be brought to the denominator, because it's we have done this, right? It was in the denominator and we have written in this way, and this is in the numerator, so that could be brought down. So that's the transformation over here. Pay attention in that one. So this is in the numerator, we have 2 times 1 minus u square into minus 2u, right, for the first term. I mean this stays in the numerator, no change, plus 8 times zeta square into u, okay, and in the denominator this comes down, it's 1 minus u square whole square plus 4 zeta square u square. We have and 3 by 2 over here, that comes down as it is, and equating this to 0, will be having something, this entire expression equating to 0 will be having that small equation which we are in search of, right? Equating to 0, this will be 0. If this is 0, this entire expression should be infinite, right? No, the numerator should be equal to 0. Make a note, please. Guys, this was evaluated for dm by du, which is equal to minus of half, right, which is equal to 0. As I have erased the denominator because we don't need the denominator. This should be equal to 0. If this is equal to 0, that's meaningless. And what was the ratio we considered from the beginning? It's omega by omega n being equal to u, isn't it? Adjusting this frequency, working frequency, to resonant frequency, that will give us it's let's say omega r resonant frequency by omega n. Let this be ur, okay. So this is the expression which we are in search of, and recollecting this one over here, what is that? dm by du, which is equal to only the numerator, okay, so minus 1 into, what's that, 2 times 1 minus u square into minus 2 times u plus 8 zeta square into u equal to 0, okay. Guys, plugging in u equal to ur, which will give us something which we are in search of. Let me tell you, let me derive all the expression and let me show you what we are searching for. U equal to ur in the expression, okay. So that will give us, implies this negative and this negative goes away, and the multiplication gives us 2 times 2 into 2, 4 times ur, 4 times, guys, u with ur, that ur, right, 4 times ur for this and this into 1 minus ur square plus, no, this will be negative, this negative will be applicable over here, negative 8 times zeta square ur, isn't it, equal to 0. So what will be this? Implies 4 ur minus minus 4 times ur cube minus 8 times zeta square ur will be equal to 0. Guys, this entire term minus 4 times ur all that side, and guys, something can be taken out as common from here itself. From here we have something common, isn't it? That is 4 can be taken out, simplified over here. You are taking out that, and if 4 is taken out as common from all the terms, 4 goes away, minus this will be 2 times zeta square ur, which is equal to, it's a negative going that side, it will be positive, right? It's 4 times I mean no more 4 times, it was taken out as common, right? So, and guys, it's ur into ur square. I'm very sorry, this is ur cube. Okay, it's a ur cube. I'm very sorry for the mistake, I've taken it back. So this will be it's negative this side, going that side it will be positive. 4, no more 4, I'm very sorry, it's a ur cube. Did I go wrong? No, I've taken 4 as common from all the terms, so we are left with only ur over here. Yeah, this 4 has gone, no more 4, and this will be 2 times, and this is this side, only this negative being sent to that side, right? So taking out ur as common from all the terms, I mean it's 1 minus 2 zeta square, okay, which will be equal to guys, this one, and it's ur into ur square, isn't it? So we don't have this anymore, we don't have this anymore, and this modification into 1 by 2 overhead. What is this? This and this gets cancelled, and we got that one. I was in search of this ur is equal to 1 minus 2 zeta square. We have under root 1 by 2, that could be written as under root also. And yeah guys, this is an important, this is a game changer. Yeah, making use of this one, we could yeah, resonant we can evaluate the expression for peak, resonant peak, mr, we gonna derive the, how can that be? What did we have? M was, if I'm not wrong, it's 1 over under root 1 minus u square whole square plus 4 zeta square u square, and we had this one, this under root over the head, right? And guys, when this is plugged in with this m will be, this m here, the secret, m will be equal to mr when whatever u is plugged in with ur, and this is the expression, mr is the expression for resonant peak. Okay, so this is the expression which we are in search of. So plugging in, what is that ur? This is the one which is to be plugged in, guys. If ur is this, what will be ur square? We have that ur square, isn't it? If ur is this one, entire this one with the root, ur square will be equal to 1 minus, root gets cancelled, squaring on either side, 1 minus 2 zeta square, isn't it? This ur, yeah, this one is plugged in over here, and this m will be equal to mr when u is plugged in with ur. So that gives us 1 by, here we have that root, okay, so we cannot neglect that root. Let me write, usually forget it, 1 by 2 root, the whole root, it's a 1 minus u square, it's this, it should be, it continues, okay, it's in, this one is in the bracket, but it's a negative, so minus 1, this negative and this negative, that becomes a ur square, isn't it? 1 minus plus 2 zeta square for this one plus 4 times zeta square and u square, guys, it's yeah, this one, this entire expression is plugged in with ur, right? So ur square is this into 1 minus 2 zeta square. Okay, so this gets simplified to, guys, 1 minus 1 gets cancelled, and it's a 4 zeta raised to, this square is applicable over here, right? We don't have this anymore, but it's a 4 zeta raised to 4 plus this again 4 zeta raised to 2 minus 8 times zeta, it's a 4 2s are 8, zeta square into zeta square, that will be 4 raised to 4, right? This, and we cannot neglect this root 1 by 2. Guys, watch carefully. It's a 4 times zeta raised to 4 minus 8 times zeta raised to 4, that will be 4 times zeta raised to 4. Okay, so I'll no proceeding further, I'll be simplifying here itself. It will be 4 zeta square minus 4 times zeta raised to 4. From here, this one and this one, this gets reduced. It's a positive 4, it's a negative 8, so it will be negative 4 times zeta raised to 4. So in that case, let me take out 4. Let's take out 4 zeta square as common from both. This will be left, and here will be having minus 4 zeta raised to 4, right? Zeta raised to 4 has come out. So what will be inside the bracket? It's a 1 from here, and minus this 4 that left over 4 has come out. 4 raised to zeta square has come out, so we'll be left with zeta square, and we have that under root. Okay, so applying this under root over here, our MR expression for the final expression, that expression which we are in search of, will be equal to 1 by, guys, a root over here, this will be 2 zeta under root 1 minus zeta square. Guys, our final expression for, we have this one. Okay, I've written it somewhere else, it's away from the ratio, 1 by resonant peak, the maximum value of magnitude of the closed loop transfer function at which it occurs, the maximum value, which is very, can you go back to the time domain specification? This is very much similar to overshoot. Yeah, there is a relationship. In the time domain it's a overshoot, and in the frequency domain it's a resonant peak. Make a note, please. Yet another important time domain specification, it's a bandwidth, and a small assumption over here similar to this one, for that to obtain that expression for bandwidth. U is equal to omega by omega n. Let another value of omega, let it be omega b, the bandwidth which we are in search of. Okay, so omega n, omega by omega n, it's a u. Omega r by omega n is u of r, or let this be u of b, some ratio, right? So over here, and guys, you have to know the definition for bandwidth. They have defined it, like the definition for bandwidth goes like this one: the magnitude, the value of magnitude, that frequency at which the magnitude falls to 0.707 of its actual value. It's nothing but 1 by root 2. Check in your calculator, 1 by root 2 will be 0.07. Okay, so that is this, the bandwidth expression for bandwidth will be equal to the magnitude, when the magnitude, this one, when the magnitude this is equal to 1 by root 2. That's the expression for the bandwidth, right? The derivation for the expression for the bandwidth starts from here. And guys, squaring on either side, it's square and square. This square and root gets cancelled, and yeah, this square and this root gets cancelled, and cross multiplying here, cross multiplying, this will be equal to this, isn't it? So in that case, 1 minus u square, and it's ub hereafter. Okay, it's not, we have defined, so we have to plug in u with a ub. It's a whole square plus 4 zeta square, ub square being equal to what? On cross multiplying we get it 2, right? So it's a, guys, this one, it's a a minus, expanding this to a minus b whole square. These are a here, this one is our a and this is our b. Okay, so if that is the case, what we have, it's a for my for it let me write like this for me to be easy. It's a square, a square, a minus b, right? Minus 2 times a into b plus b square, isn't it? Plus it goes on. So what's our a? It's a 1 minus 2a, it's a ub square. Okay, it's a ub square, and ub square whole square. These are b, entire expression is a b, right? So, and going ahead, it's a 4 zeta square ub square, which is equal to, guys, minus 2, which is equal to 0. Can this be written? Of course, it's positive. Shifting this to this side, that will be negative, which is equal to 0. And what is this one? It's a 1 square, so 1 minus 2 ub whole square. Okay, plus ub raised to 4, right, plus 4 zeta square ub square. Guys, positive 1 minus 2, let this be minus 1, which is equal to 0, right? And guys, it's a ub raised to 4 minus 2 times ub square as common from this one and this one. So what do we have? 2 has come out. Okay, 2 minus 2 ub square, it's a suffix, please don't mind my handwriting. Minus 2 ub whole square minus 2 ub square as common from this and this. So here we'll be having 1. Okay, minus has come out, so minus 2 times zeta square, because 2 ub has come out, we are left with 2 zeta square. Yeah, this is the case. And minus 1, which is equal to 0. Guys, small assumption over here for the derivation to be simplified. Well, let us assume ub raised to, ub square equal to x. Let that be. Let us have this simplification for the expression to be easier. Well, later on we will plug in with wherever come across x, that will be plugged in with the ub square. Okay, so if this is the case, it's a ub square whole square, right? So this could be written as a ub raised to 4 ub square whole square. So ub square is x, so this could be written as x square. Okay, minus 2 times 1 minus 2 zeta square into x minus 1 equal to 0. Guys, now this is a quadratic expression. X square minus a square minus ax square plus bx plus c. It's very much similar to that quadratic expression, right? So what is our a? A in this case is 1 from here, and b will be equal to minus 2 times 1 minus 2 zeta square, and c will be equal to minus 1. So what are the roots for the quadratic expression? As from you are making use of that roots for the quadratic expression from your schooling, previous grades, right? What it says, 2 roots, so x1 comma x2, 2 roots, that will be equal to minus b plus or minus under root b square minus 4ac, and the entire this one is divided with 2a, right? By b square minus b plus or minus under root b square minus 4 is by 2a. Yeah, of course, I'm not confused, thank god I didn't miss it. So what we have, the roots are, guys, a minus b, in the sense minus of this one, so it will be straight away 2 times 1 minus 2 zeta square for this one, plus or minus under root, it's a b square again, in the sense 4 times 1 minus 4 times into 1 minus 2 zeta square whole square minus, guys, 4 A is 1, C is minus 1, so this negative goes away. It's a positive, it's a 4, okay, by 2. Considering the positive value, it's a plus or minus that thing. Considering the positive value, what we have is, let that be x positive value. It's guys, in this case, a small simplification here itself. This denominator 2 and this numerator 2 will be cancelled, and from that one we have 1 minus 2 zeta square and plus, as I've just told you right now. And here also this 4 and this 4 coming out of the root, that will be 2, and this one gets cancelled in that case, right? So in that case what we have is here, it's a, did I confuse you? This 2, this 4 from here, this 4 from here taken out as common from here, and coming out of the root, that will be 2, and that 2 and this 2 gets cancelled. Check again, right? And in that case this 2 and we don't have this 4 anymore, it's 1. We have this root, okay, that root cannot be neglected. It's a minus b whole square again, a minus b whole square, that will be a square 1 minus 2 times of 2 zeta square, that will be minus 4 zeta square, plus this whole square again, isn't it? So that will be 4 zeta raised to 4 plus 1, because we have that one, 4 came out, so we'll be having left with that one. So x, going ahead, x will be equal to 1 minus 2 zeta square plus under root, it's 2 minus 4 zeta square plus 4 zeta raised to 4. Guys, this is for x, okay, this is for x, this expression is for x, which is equal to this one, x, this is for x, one of the root with the positive value, which is equal to ub square, right? And from this one what we have, ub will be equal to the entire root, squaring on either side, mean root on either side, that will be 1 minus 2 zeta square plus under root 2 minus 4 zeta square plus 4 times zeta raised to 4, and we have the entire root over here, root on either side. So guys, this is for ub still, which is equal to omega b by omega n. So from that ratio what we have, we are in search of that omega b, that expression for bandwidth. So right, omega b will be equal to omega n into entire this one. From here omega b equal to this into this one, it flips up, so omega n into 1 minus 2 zeta square plus under root 2 minus 4 zeta square plus 4 times zeta raised to 4, and we have that root 1 by 2, we have that root. In other textbooks you have under root over like this entirely, we have that root, we have, guys, I stress, we have root for this entire expression for the bandwidth omega b. Guys, it's another important time domain frequency domain specification. Generally you people neglect that, we concentrate on the time domain specification, we neglect that frequency specifications, but still that gives a sudden surprise for you in the exam point of view. You find it and you will start thinking, where did this come from? So it's better to get ready with these expression also, right? Hope you understood the analysis. We have phase margin also, try with that one, okay? So if you have any doubt, if you have find any tedious job while evaluating the phase margin, I'll do it for you. Just drop it in the comment box. Thank you for watching.